Hi, and welcome to my channel. And today I'm going to be going through how to model the Motor Vertex on a Mini-Kosell. So this is my finished product. As you can see, it resembles almost identically various Mini-Kossels that you have seen. With some exceptions, I put my name on it, and I'll show you how to do that. And some of the other exceptions are I did a sweep here. Other models have two sort of pocket things, and frankly I just found them too cumbersome to do. And I also did a sweep here, and just similarly they were, they had two pockets, or two geometries, two separate geometries moved, and it seemed overly complicated for FreeCAD. Maybe it's easier in others. You can see it, for some reason it didn't mirror over here, but that might just be what I have selected. Anyway, so you see I have the motor mount. I've included access holes to the motor mount screws on both sides. You see that? And one thing I'll be trying to remember to do differently is to have this filleted. I'd like to have a fillet from the sketch instead of an after-the-fact fillet. I just find that they, maybe not, maybe for comparison we'll do one in the sketch and one afterwards. I just find at this point my computer's going so slow, I guess that works just as well. So we'll do one final fillet for everything, and maybe I won't do the fillets in the sketch. So I'm going to show you first this sketch, and then we're going to recreate that. So this is the basic body design. So you see I have these fillets here, but none here. So this is the basic body design, which we'll be repeating in the first part of this tutorial. So before I close that up and get started, I want to show you what version of FreeCAD I'm using. So we do an about FreeCAD, and you see I'm using 0.17. This is the daily build from the Git. I think it's a couple of days old now. And I'm just going to copy that to the clipboard. And in this particular example, I'm just going to be using Sketcher and the Part Design Workbench. So these are included in your basic install of FreeCAD, so you won't need to download anything extra. A second point of interest before we go any further is to take note of your Blender, of your navigation tool right here. This is a new feature of FreeCAD, which I think is a tremendous feature, and it lets you it shows you, if you hover over it, you'll see what, how you navigate with this particular one. And if you click on the arrow, you can pick the different types of navigation. I use Blender because I kind of got started with Blender, so I naturally tend towards that. But I highly recommend that you understand your navigation first and get really comfortable with it, because when I first started with FreeCAD, a lot of my confusion was around the navigation. And I think it defaults to Open Inventor, and I wasn't familiar with that at all, and it created confusion for me. So definitely spend some time and understand your navigation. So to begin this project, I've created a new document, and I'm going to add a part, a body, and a sketch. I'm going to select the XY plane feature to map it to, and click OK. The first piece of geometry we're going to create is a triangle, and that's going to be a construction geometry, and that's going to aid later in getting all our parts to line up and correctly. So we're going to do two lines to form the vertex of a triangle, and this will connect later to the rest of the body. We're going to add an angular constraint to this. I believe that's what it's called, fix the angle, okay? And we want that angular constraint to be 30 degrees. Because the entire vertex is going to be a 60-degree basis. Later on, we'll be adding a mirror constraint to this. We're going to set the length of this leg of the triangle to 32 millimeters. Next, I'm going to be drawing the basic geometry of this shape, and we'll be going to use the polyline tool for that. So create a polyline in the sketch, and I'm just going to freehand the shape here because we will be setting the lengths and the various constraints later on. So I'm going to freehand this shape, and then I'm going to move it around just a little bit. So it kind of looks like the final product. And the reason I do this, the reason we want it to kind of look like the final product is when you're adding constraints, if it's too far off the norm of your end product, sometimes lines get moved across each other. I'm going to be getting rid of this constraint because it's not going to be used and it will get in the way. Now I'm going to draw the inner shape, again using the polyline. And this is where the motor shaft protrudes and the timing pulley resides. And also I'm going to just kind of shape this a little bit better. Now I'm going to add the filleted radiuses for these corners by using this tool. It's create a fillet between two lines or at a coincidental point. So we're using the coincidental point. Okay, I'm going to leave this unfilleted because we're going to do that at the end. And the final geometry I need to add is these perpendicular lines, which will be the stopping points for the 2020 extrusion. Now we want to go around and set the lengths for all of these. Now, not every line will get a length because some of them will be bound by various constraints, various other constraints. So we only need to set a certain number of these. How you go about determining that, I don't know if there's a particular way other than as you're building it. I don't know what I selected by mistake there. So I don't know if there's a agreed upon methodology or not. So I'm going to be setting this to 16 millimeters. So these measurements came from an existing Kossel that can be gotten from the rep forum. So I need to set this distance because this is a broken line. It's not going to carry through. So that is also going to be 5.5 millimeters, and this one's going to be 5.5. And this we're not going to get a distance for. That's going to be set with an equals constraint later. This is going to be 4 millimeters. And this will be corrected later on. That will be constrained by other means. Let's move these where you can see them. So the two final measurements are going to be this distance. If I can click these little dots. And that's going to be 28.5 millimeters. And you can see I'm kind of way off on. No, that doesn't seem right. Now let's set this and see if it fits. So this is the final measurement. Final measurement, we're going to set this radius to 4 millimeters. See if that helps us out there. Nope. So and this is what I mean by being kind of close to your final, because this kind of thing just really messes you up. There we go. So that's close enough. The constraint solver can really just throw stuff out of whack. It's got a lot to. I'm not faulting it. It's just got a lot to think about. Okay, so those are all the distance constraints, and we're going to move back. We're going to move on from there. So now we're going to set the equality constraints. There's only a couple of equality constraints, and you'll see how it'll start to even take up, it'll even start to shape up even more. So these will be equal, and then this centerpiece will be equal. The next set of constraints are going to be perpendicular, and those we can just accomplish by going around the perimeter. So we'll select that, each of the perimeter items in order. You see how it'll start to fix some of the stuff up. That's not going to be perpendicular. This will. This will. And that will. The next set of constraints are there's going to be 4 mirror constraints. Or, I'm sorry, symmetry constraints. I don't know why I always say mirror. But anyway, so these 2 endpoints will get a symmetry constraint. We'll get a symmetry constraint on this line here. We will get a symmetry Now some of these maybe, it might not matter. You might be able to do it off this point. I don't know. This is how I did it. And one final one on these 2 points here. Okay. So next we're going to set a couple of angles, and we're going to add the front curve. So the angles we want to add are from here to here, and that's going to be 120 degrees. And then from here to here. Now, I'm not sure, I want the acute angle. Sometimes FreeCAD gives me the obtuse angle here, and if I don't know how it chooses that. Fortunately, this time it gave me the right one. So that's going to be 30 degrees. And you can see how everything is just starting to snap into place the way we want it. So the final thing we're going to be doing is adding this front curve. So the front curve is going to be added using the arc tool. Let me just highlight this so we can see, create an arc. And we're going to be using the two endpoints and midpoint, or rim, sorry. And the endpoints we're going to use are the ends of these extrusion stops. So I'm going to go from that extrusion stop to this extrusion stop. And then I'm going to coincident on this construction geometry. Now you know why that construction geometry is there. Next, I'm going to set the center point of this arc to the x-axis here. This is the center point. Nope. Let's see. There's the center point. Okay. So I'm going to select the center point. I'm going to select the x-axis, and I'm going to select the fix a point onto an object. And you can see what happened is our lower line here changed its geometry because it's constrained to this arc. So eventually, it was one final step. We'll make those exactly the same. I don't think they are right now. Let's check. Oh, they are. Okay. But we're going to set this final constraint here. So we're not fully constrained in the sketch yet. So we have a few more steps. So I'm going to be, and I think one of the freedoms is this. Yeah. So we want to set this to be a certain distance, and it's going to be 30 millimeters. So we're going to set that to 30.5 millimeters in distance. So you see we're down to 2 degrees of freedom. Okay, so I had to hunt for the last degree of freedom, and it was a mistake I made. First of all, I want to remove these 2 vertical constraints because they're not necessary. And the way I found the last degree of freedom was just checking each dot and line. So, that can be very hard to find. And one of the things to keep in mind is as you move each thing, that counts as an undo task. So if I try to move something and it doesn't move, if I hit Control Z, that counts as an undo. And that's important when you're trying to move back and forth through undos. So finally for this sketch, all I have to do is select those 2 and constrain them. And now I have my fully constrained base sketch, and we're ready to pad this. So we can close out of this sketch, and you can see that's starting to look something like a Kossel. And the next step will be to pad this, and this is going to get padded to 60 millimeters. So we're going to be doing the single shape version instead of like on the FL Sun it has two pieces. We're just going to be do the one shape. So you have this is your basic shape, and the next thing we'll be doing is adding the 2020 extrusion sketch. Now that we have our basic shape for the Mini-Kosell Motor Vertex, we need to do a pocket to cut for the 2020 extrusion to be inserted, the vertical 2020 extrusion, among some other things, but that's what we'll be doing next. I'll show you that in this completed version. So in the completed version, you can see, oops, let me close this. Yep, there we go. So you can see this will be the sketch we'll be doing. So it'll just be the outline shape of the 2020 extrusion. It's a very fairly basic shape, but a lot of equality constraints. So let's go ahead and move on to do that. So to start, we'll select the top plane of the shape we just created. As you can see, the z-axis is pointing up, and we'll add a sketch to that plane. And we can leave this object in the background. It may help a little bit, but we're going to zoom way up so it's easier to do the shapes. So to begin with, we're just going to do a rough outline of the shape with a polyline tool. And the important thing here is not dimensions, it's just making sure that each line has either the vertical, or in this case you see the horizontal constraint, because that's going to be an important piece of keeping the shape the way we want it. So I'm going to go through and do all four sides like this, and you see, just make sure you get that constraint on each one. And then after we've created this shape, we're going to be doing, there's three sets of equality constraints we'll be doing. And what you want to make sure is you don't get a constraint with that axis. That would make this a lot harder. Oops, so see that one, I missed the constraint, so we'll have to add that back later. We'll do that right after we finish. And I think I missed it on that one too. Okay, so now I'm going to add the vertical and horizontal constraints that got missed. One right there, and one right there, and then that's good. Now we're going to go around and add. We're going to do lengths, and then we're going to do we'll do equality constraints. So there's only four lengths that we're going to, or dimensions that we're going to add, and it'll be two horizontal dimensions. So this will be 20.25 millimeters. So it's going to end up with 0.5 millimeter tolerance. So, and we'll set that same thing on this axis right here. That'll also be 20.25 millimeters. Okay. And we can move these around a little bit if you want to, or not. And so we need to set this to 3 millimeters, and that's just a guess. Basically, you need a bit of a bump to catch to orient the rail or the extrusion, and then finally we'll set this to 5 millimeters. Okay, and those are all the measurements we need. Everything else is going to be set with equality constraints. So we'll move on to the equality constraints. So we have three sets of equality constraints, and it's these larger lines, these vertical ones, and then these inside horizontal lines. So first thing I'm going to do is I'm going to select all of these. And it's one click for each one. And I'm just going to set them to equals. Okay. Now I'm going to set, I don't need to move that, but now I'm going to select all of these. and set them to equals. And you can see it's taking its final shape. Now I'm going to set these inside, these inside edges, and set them to equals. And that's it. That's our shape. So the final thing we need to do is to set that. Let's see if it's. So it has 2 degrees of freedom. I'm not sure. The funny thing is sometimes finding the degrees of freedom is very difficult. So the final constraints we need to do to fully constrain this object is we're going to use these 2 points and this line of symmetry and a symmetry constraint, and that puts it into the center of this object. And then we're going to offset the we're going to offset from here the front edge of the extrusion cutout to the front edge of this curve. We're going to offset that by, so the x, where the XYZ 00 or intersection is the same as the middle of this front curve, and I did that on purpose. So, and that way I don't have to have an external geometry. So we're going to set that to exactly 6 millimeters. And that's it. Now our sketch is fully constrained, so we can exit. The final thing I want to do with this sketch is make a pocket all the way down to the bottom. So with the sketch already selected, we're going to select the pocket. And instead of dimension, we're going to go through all. And as you can see, that goes through to the bottom. And finish that by clicking OK. And then we're done with the 2020 extrusion cutout. So once you have finished the 2020 pocket, extrusion pocket, we're going to be adding rail guides along the side. And those are for the 2020 extrusion to be held perpendicular to this end stop here. So there'll be rail guides, and let me show you on the finished piece. So we'll be working on these rail guides and these holes, and we'll be using a mirror to put them onto the other side. So let's start. Let's start by selecting this plane, and actually before we do that, let's make sure this body is toggled to active, and we'll select this plane and add I need to be in the sketcher. Let's go to part design actually and select a sketch. And that's a pet peeve of mine. I wish there was an indicator showing that this was the active body. I'm going to try to suggest that. So now, okay, so we have our side view here, and we're just going to do 2 freehand boxes. And we're going to set the dimensions of the box of the boxes. We're going to set the side dimensions, and it's going to be set to 5 millimeters. And then we're going to set equalities to here. We don't need to on the other side because we're going to be leaving these horizontal restraints, and we're going to set the distance between these to 35 millimeters, and that's incorrect. It should be between these 35 millimeters. And then we're going to use the external geometry to select this upper line, and we're going to set the distance for the external geometry from this corner. We'll set that to 7.5 millimeters. And then this, let's select this temporarily. So you'll see that even though I hovered over that, it didn't change because it's basically behind this axis. That's frustration for me. So that should be 7.5. Okay, good. So I don't need that constraint. I was just using it to make sure, because this is supposed to be equal. So let's get rid of this external geometry, and let's select this edge here. We're gonna coincident these two. I'm sorry, wrong one. Need the line, not the dot. Okay, and let's set these to equal. And let's coincident constrain that. That's my bird clock. I have a clock that does a bird call at the top of every hour, in case you're wondering. So that's that sketch finished. So let's move to pad this. So we're going to close that sketch and click pad, and we're going to make this pad only 3 millimeters because it's just a guide. It's not actually, that might be even too tall. Let's make that 2 millimeters. I don't want it to interfere with the bolts that go into that are inside the rail when you construct it. Okay, so now that that pad's finished, now we're going to add right onto this plane, we're going to add the circular cutouts. And I'm not certain, but I'll have to test it. Actually, I'm going to mirror this first and then do the cutouts, because I think I need to do separate mirrors. So we're going to mirror this, and you see they're off in the distance there. We're going to mirror this on the XY axis. So after mirroring the guide rails, we're going to add the mounting holes. So select this lower plane of the mirror, of the resultant mirror, and create a new sketch. Let's zoom up on that. We're going to add a circle, and we're going to set the circle radius to 2.75. We're going to select an external geometry to the bottom edge, and we're going to constrain the center of the circle to 10 millimeters above that, and that sets it right into the center of that rail. The next constraint we're going to add is this horizontal distance, and we're going to set that to 9 millimeters from the edge. And I don't know that that's a critical distance because you're fastening it to a sliding rail. The next thing we're going to do is we're going to use a feature of the Sketcher workbench where we're going to create an array. So one of the things that you'll notice is this angle here. Don't even try to get it to 90. You're not going to get it. So I just go in and enter that afterwards, straighten it out, and then we can move, and hopefully I think we should be able to drag. Well, let's get rid of this dimension for now, and I should be able to drag that over it. Yep, okay. So now we're going to set this dimension to 40 millimeters. I got pretty darn close. And then we're going to add a dimension. Oh, I guess this dimension doesn't really matter too much, but let's just pick a nice round number. Let's say 35. Does that look good? Now let's try 40. So, nope, that's too far. I want it to have that kind of same distance there. 35 is good. Good enough. This is arbitrary, it doesn't really matter. So once you're finished, so we've got 90, 40. Okay. So I ended up going with 38 millimeters there, based on my previous drawing, and that's your final sketch for the hole. So you can close that sketch, and then we'll just be creating a pocket with that. Now, for some reason, if you try to do through to all, well, through to all will cut into this side. If you do to up to face and select a face, for some reason it only picks one hole. I don't know why. So you have to use, in this case, you have to use dimension, and I think 7 millimeters will get us through. And I'm going the wrong way. My computer's going very slow today. There we go. So let's try to redo it. See what happens. Okay. Nope, 8. Okay, that gets us all the way through. Okay, so now that we've got those, we're going to mirror those. So you pick the last feature you did to mirror. Now I have mirrored stuff further back in the history, but I think that's a really bad idea to do. It's FreeCAD. You need to be working on the last thing. This is less of a tree and more of a history. So if you think of it as a log and not a tree, that's a good way to think of FreeCAD. So we're going to do our mirror, and like before, we're going to pick this XZ axis, and then we have our holes on the other side. So that mirror feature is a great, it's a tremendous time-saving feature. You'd have to sketch the other side otherwise and redo the whole thing. Okay, so the next thing we're going to be doing is the motor mount. The next step we're going to go through is adding the holes for the motor mount. So you'll be selecting the rear-facing plane and add a sketch to that. And we're going to draw 2 circles, one for the motor shaft area, and on NEMA motors there's a cutout. It sort of extrudes out or pokes out about the size of that hole, and we're going to do another one down here. This is going to be where the screw holes go in, and we're going to array this around. So first let's do the large hole. So we're going to need to set the radius of that, and its radius is going to be 12 millimeters. We're going to constrain it to the center axis with constrain a point to a line, and then we're going to, let's see, we're going to set that we're going to pick an external geometry to the bottom of the body, and that's going to be, we're going to set that to, let's go zoom up, let's set that to 30 millimeters above the bottom, so it's exactly halfway on the height of the body. So let's set this center to 15 millimeters, and this is nice and symmetric. And let's set its height from the baseline is going to be also 15 millimeters. So you gotta love symmetric. The radius of the screw hole is going to be 1.75, so it's a 3.5 millimeter screw. So that's our basic sketch. You can see it's constrained. Now we're going to create an array. So dark green is selected, select the array tool, and it's going to be a 2x2, same as before. And I'm going to show you, if I go out into the horizontal thing and I try to get it at 180, so you never get it, it reads too detailed, I think. So we're going to change that to 180, and we're going to slide this, we're not going to slide it up, we're just going to set the, there's the radius, where is it? Oh, there it is. So this will be set to 30 millimeters. You can see the symmetry still. 30 millimeters, loving it. And then we're going to set this one, I think, is also going to be 30 millimeters. Yep. Okay, and that's it. I think that's our sketch is fully constrained at this point, and we have all the elements we need for the motor cutout. So we close this. So the next step for the motor mount is to create a pad. So with the sketch selected, or a pocket, I'm sorry, I misspoke. Click the pocket tool, and now we're going to try through all, but you'll see that it goes a little bit overboard and just goes through all, which might be desirable because these could be great access holes for screwing in the motor, but they compromise the visual appearance. So we're not going to do that. We're going to go through to first. So what that does is it's going to create a pocket through to the first face. So it doesn't stop at the first face. It stops at the opposite vector maybe, or the opposite, I'm not sure, but it cuts through the first face it finds. So that's a good feature. Okay, so that's it for the motor mount. Now we're going to move on. So the next piece we're going to add is the vertical mounting holes for the vertical 2020 extrusion. And we're going to do so by selecting this interface, and we're going to add a sketch to that. You'll see that it's obscured. That's okay, we're just going to hide that part. But before we do that, we're going to select two geometries. This vertical line, oops, not that dot, and that horizontal line. That's my bird clock in the background saying it's 9 o'clock a.m. So once we've selected those external geometries, we're going to hide the main body, and we're going to add two circles. Now you could do this with that array tool, but I think that'd be a little bit of overkill. So I like to build them to the side so it's easier to see what I'm doing. So we're going to add a radius, and the radius is going to be 2.5. Oops, sorry. Let's reorient the sketch there. So the radius, I don't know why it's not picking it. So it's let's try that again. So let's pick the 2. And yeah, so it should ask me if you want to share it. I'm going to say yes. And it's going to be 2.5 millimeters. Okay. And we're going to constrain these to the center line of this sketch. And where's that? There it is. And the same for this one. So you can see that puts it dead square in the middle of the 2020 extrusion. So this is going to be distance from the bottom of the sketch to 20 millimeters. And this distance from circle to circle will be 30 millimeters. Now I think that's generally arbitrary, but that's based on the Kossel, the original Kossel. And that's done. That's it for the sketch. So we can close the sketch, and now we're just going to create a pocket. And in this case, we're going to say through to all because it's in the correct direction. It's not going to hurt anything else. There we go. So those look a little high to me, so I'm going to check. I'm going to check with the maybe not. All right, we'll leave those for now, and if I'll come back to it if they end up being too high. The next step in our project is to add a cutout for access to the adding fasteners to the 2020 extrusion. We're going to be adding a sketch to this plane, and it'll be an octagon. We're going to do it on the top. Okay, and let's pre-orient this a little bit so it makes sense. So we'll orient it some this way. Let's zoom up. So we'll put it about where it's going to land, and we'll select some external geometries. So the first external geometry, or the only external, I think we need this one, and maybe this one. I'll delete it if we don't need it. So the first thing we're going to do is set the distance from this internal edge. It's going to be 4 millimeters. Oops, it's going to be from this line. Okay. So that'll line up with the internal, with the structure of the 2020 extrusion. The next thing we're going to do is we're going to set the full width of this. This is I guess we could set the radius as well, but I chose to do it this way. And it's going to be 12 millimeter. So let's just check to see if the radius ends up being 6. No. So what I did was I measured, this cutout matches the width of the 2020 extrusion. So I didn't have a radius, so that's why I did that. And then the setback from this is going to be from this edge, so from this edge to this line, and that's going to be 5 millimeters. So, and I guess the final thing we'll need to we'll just set one of these as tangent, so that locks it in place. Okay, so that's our sketch, and we're going to be sweeping that down around a path. So let's close this. Let's move to that side. The next step is to create the sweep path for this sketch. So this sketch is going to be swept down from this face into the body to this face. So we're going to put a sketch for that right here. So there's our sketch plane, and the external geometry we're going to need for that is not this edge, but we're going to need that point, and we will need this edge. So with the external geometry selected, so I got that point from this geometry, so it just canceled that one out. So with that selected, I'm going to hide the body. Sounds like I'm doing a crime. And we're going to create a, let's do it center and endpoints. So this is going to be this, nope, the center is going to be over here, so we'll just do that for now. And this will be one endpoint. This will be the other. So it doesn't really matter how far the arc goes, it just matters where it starts and the radius of it. So I need to constrain this to this endpoint. And let's make sure this center point is constrained. Yep, it is. No, that didn't constrain. Okay. There. Good. Okay, so now we want to set the radius, and the radius in this case is going to be 2.5 millimeters. Yep. Okay, so this, that. Now, I guess ideally I should cut this octagon off, because when it sweeps, it's going to sweep this edge down and this edge up along this axis right here. So you'll have this weird geometry that's isn't visible, but it exists. So let's bring the pocket back. Let's close the task, and then we'll perform the sweep. So now we want to create a sweep, and we're going to be sweeping this octagon along that little path. And so with that selected, we're going to select subtractive sweep. We're going to add this edge as the object, and we're going to click OK. Now, for some reason, it's saying these objects are not part of the active body, even though they appear to be in the model. I don't know why. And whenever I click Make Independent Copy, it crashes mine. However, I can create a cross-reference, and that seems to work. So that might be a workaround. And then I don't really see what what the difference ends up being. So I've got my two sketches still. They seem to be part of the body. Don't know what's going on there. So I'm going to look in the report view real quick just to see if there's any obvious errors. And starting here, maybe, nope. That's, yeah. So I don't know what, I don't know where else to look for errors. Maybe there's a log. I think there's a FreeCAD log, but it works, so I'm going to leave it be. So this subtractive pipe, I need to create a mirror over to here. And I'm going to do another sketch down here. So I'm going to do the sketch down here first. Actually, I'm going to do the mirror first. We'll do a mirror up there. And we'll do it along this plane. So there it is on the other side. Okay. And so then we would do the same thing here. I'm not going to record that. I'm just going to go ahead and complete it, and then I'll come back. Okay, so I completed the process on the bottom, and now you can see I've got nut access on all four sides of the model. Now I can see I'm going to have to adjust this. You can see how that goes through about the middle, and this is not the same. So I'm going to have to figure out what that is. So if you print this, this probably won't give you full access, whereas this one will, or not sure. Not sure. So keep that in mind if you print it. Okay, so that's the nut access. So now that we have finished adding the nut access, we're going to add wire access in the middle of this plane. And I'll show you on the finished version. We'll be adding this, and so this will be a sweep along this plane. And one of the things this is going to demonstrate is that the sweep path doesn't have to be concentric to the, I mean, you saw that on these, but I'm going to show again how the sweep path doesn't have to be concentric to the item being swept. So we're going to start out by adding a sketch to this plane. And sometimes I have to reorient to see where I'm at. So, and it's going to be an octagon, and that'll be added somewhere in the center here. Oop, a little bit big. Let's make it smaller. Move it, and we're going to just make one of these vertical. And let's zoom up. So we're going to remove the equality. We're going to turn this a little bit so we have an easier one to work on. You'll see why. I don't want to have to fiddle through all of these. So I'm just going to remove the equality constraint on this and on this. And then I'm going to reset them just to be only equal to each other. Just want to check to make sure I'm recording. Sorry. So now I'm going to set the length of this one to 4 millimeters. And we're going to set we're going to set the length of one of these segments to 8 millimeters. And that, you'll see it's resized all of them. And for some reason this is dragging. There we go. So 4 millimeters and 8 millimeters. And then now I'm going to constrain this to this edge. So I'm going to use the external geometry and select this edge. Oh, I'm sorry. So to select this edge, because this is just an intersection, if you grab this one right here, it'll project down to your sketch. So now I'm going to constrain this to that edge. And this as well. So it makes it... So one thing I don't like is once you've selected this plane, your sketch, it highlights behind your sketch. And I wish you could turn the highlighting off after you've gone in, and there may be a way to do that. So I'm going to go out of the sketch and then back in. Oops. Let's unselect it and then go back in. I'm sorry, I'm not doing that right. Anyway, let's select this and our edge. Constrain it. So now it's oriented to correct the way we want it, and we just need to give it a radius. And the radius will be, oh, I'm sorry, we don't need to give it a radius. We gave it an effective radiuses because this is a circumscribed octagon here. So we gave it an effective radius. So you can't change the size of it. You can change the position, and that's all. So this doesn't really matter where it sits per se, I don't believe. So let's just set it about the center, and that's good. We can move that if we need to. So that's fine. It's not fully constrained, so it might have been a good idea to anchor that somehow, but I'm not going to do that at this point. So for the next piece, I need a path for this octagon to be swept along. So I'm going to select the top surface here. Now in my other model, I did it with a radius that went from here to here. I'm going to change this time and use a B-Spline. Just one, because I like using B-Splines. They're fun, and it seems like they've the awesome developers over at FreeCAD have improved the sweep along the B-Spline. I had some trouble with it before, but it seems to be working better now, but it's still awesome. So I'm going to add a sketch to this plane, and I'm going to select two geometries, external geometries, the edge of that and the edge of this, because I want my sweep to come out through the middle of this and enter through the middle of that. So now I'm going to add a B-Spline to that, and the B-Spline is this tool right here. So I'm going to select a point right here that's coincident with that line, and I'm going to put a couple of control points just so that I have plenty of control. So let's zoom up on that a little bit. Oops, sorry. Let's see if I can get that. There we go. And let's move that. So what I want this to be the center, and for some reason the mirroring tool doesn't work with this geometry. So I know this line to be 5 millimeters. I'm going to make that 2.5. So with that 2.5, we're good. And then I'm also going to make this 2.5. So I know they're in the center. So now, wrong 2.5, sorry. So it's going to be 2.5 distance, not horizontal distance. Okay, so now I want this to be perpendicular, but you can't do a perpendicular to a B-spline segment yet. So I'm just going to eyeball it. So, and I want to bring this curve out a little bit, and I want this one to be perpendicular as well. Okay. So one of the things I did notice that with B-splines is that, like, when it was making mistakes, it seemed to be sweeping it along this path instead of the other path. So again, I think they've fixed that. So I try to kind of make this path, I don't know if it's still broken or not. Oh well. I was going to say I try to make that path normal, but normal looking. So let's try doing that sweep now, and we'll see if it works. So we're going to be sweeping this sketch along the other sketch's path. It's going to be a subtractive sweep, and we need to add this as an edge. And so it's added successfully. Let's see if it's coming out the other side. And it is. It's coming out the other side nicely. So now when we finish it, we'll need to create a cross-reference, and that's only because in my version, the recommended one crashes my machine. So when that stops doing that, I'll follow the recommendation. So now I just want to look down it to make sure it looks normal, and it does. It looks good. So before I'd have it doing funny twisty things. So that's how we're going to add the wire access. So the next thing we need to do is just mirror that wire access. The last piece for this Kossel Motor Vertex is to mirror the wire access. So I'm going to select the subtractive pipe, and I'm going to click mirror and wait for that to process. And I think we're going to need to select the center axis, or the center plane, for it to mirror across. So you see it's done the mirror, and let's see. Yeah, so it mirrored it along the sketch axis. So at this point, all you have to do, and you don't even have to change this any. I thought before you had to pick from here, but I think if you just pick the plane, it automatically changes it. Yeah, it does. So you don't even have to select here first. You can just directly pick the plane. That might be a change, or I missed it before. I don't know, but that's a wonderful feature. So that's it. That's all I'm going to do for the Kossel Motor Vertex. There is an optional piece that I'll try to add a video for later. It's these Allen wrench access holes. It took a long time to add those in just the right way. You could do it just with a cylinder, a subtractive cylinder. But you know, I just didn't want to make this video any longer than it is, so I'll try to make that a separate video for that. And you can use this, you can print and use this Kossel motor mount as is. I believe I haven't printed it yet, so I'll try to add a video of it printed later. So I hope you enjoyed this. This was a long one. If you like my channel, please subscribe and click like. Also, you want to click the alarm bell, and that gets you notified of new videos. So have a great day, and thanks.